Hello again. We're looking at protons, neutrons and electrons in this video where we're still discussing the structure of the atom. In the last video I told you that the atom looks something like this. We have this big piece of empty space and it's actually incredibly small, but compared to the center, which is a little tiny dot in the middle of this empty space, there is the nucleus, and all of the weight, well, not all, but absolutely most of the weight is consisted inside this nucleus in here. Now, what does the nucleus and the electron cloud consist of? Well, I think I mentioned in the previous video that in the electron cloud, even though it's empty space, we encounter electrons. Okay, so we've got electrons in the cloud. Okay, so we've got electrons in the cloud. Now these electrons can be shared with other atoms. This electron cloud can also share atoms, electrons from another atom. Okay, so the number of electrons in an atom may vary. At some times a certain atom may have different number of electrons than at another time. Okay, so in the electron cloud, I don't want this, in the electron cloud we have electrons. Okay, now in the nucleus, inside the nucleus, we've got protons. Okay, now proton is a very special particle when it comes to the atom, because the proton decide what atom it is. The proton is absolutely constant. Okay? In other words, an atom can't share or give away his protons. He keeps his protons. A proton is the number of protons is what defines how what type of atom it is. For example, okay, gold. Okay, and the symbol for gold is AU. Okay, gold has 70, write it here, 79 protons. Okay, so if I have a gold atom, that atom in its nucleus will have 79 protons in its nucleus. Silver, on the other hand, and the symbol, the chemical symbol for silver is Ag. Silver has 47 protons. In other words, in the atom for silver we only have 47 protons in the nucleus. And for example, if gold had to just lose one proton, which I don't think is possible, it won't be a gold atom anymore, it would be a platinum atom. These are all examples of elements. Okay, and we said that an element is basically a collection of the same type of atoms, okay, together form an element. Now also in the nucleus we get neutrons. Okay, now the number of neutrons in the nucleus is roughly the same as the number of protons. Okay, but it's not necessarily the same. I can have the same number most of the time. When I find an atom, it has the same number of protons and neutrons. Okay, but sometimes they can be more, sometimes they can be less. When I have an element like carbon, carbon has 6 protons, okay, and most of the time carbon will have 6 neutrons, okay, but there's a special carbon that I'm sure all of you have heard about. Carbon always has 6 protons, but this carbon has 8 neutrons. Now when we add these two together, I get a number 12. This number is called the atomic mass. Now the reason why it's called the atomic mass is because I said before that the mass of the atom is completely consisted inside the nucleus. So the nucleus is what gives this thing weight, and inside this nucleus is protons and neutrons, and protons and neutrons have roughly the same weight. So if we add them together, we get what we call the atomic mass. Okay, this carbon's atomic mass is 12, this carbon's atomic mass is 14. Have you ever heard of carbon-14? Carbon-14 is a means in which they can date how old a specific fossil is, for example, because carbon-14 exists inside all living organisms, or at least once living organisms. I won't explain to you just now how it works, but it's a very interesting process. Now, since these two are both carbon atoms, they just have different number of neutrons. They are called isotopes. So an isotope is the same element. An isotope is the same element with a different number of neutrons. Okay, that's simple enough. So we get carbon-12 isotopes and carbon-14 isotopes. Okay, so what does a carbon atom weigh? If I could tell you that an average elephant is 5,500 kilograms, okay, can't I then tell you what an average carbon weighs? Because we're talking about the atomic mass. Sometimes it's 12, other times it's 14. But we would like to have an atomic mass that is consistent, that whenever I work with carbon, that is the atomic mass I'm going to use. Now, in order to calculate this atomic mass, what they do is they go and look at all the carbon in the known universe. Okay, so I don't know how they do that, but imagine we've got all the carbon in the known universe. Okay, then they go and look at what percentage of this carbon is carbon-12. Okay, and let's say 90% is carbon-12. Now, that means 90% will have an atomic mass of 12. Okay, what percentage of it is carbon-14? Let's say 3% is carbon-14. So 3% will have an atomic weight of 14. Okay, why? Because it's got 6 protons and 8 neutrons. Okay, and then there might be a bunch of different ones, and I don't know what their exact relationship is, but the point is the majority, the 90%, or probably much more than that, would be carbon-12. Okay, so what they then do is they say, okay, let's take these weights. Let's say some was 11, some was 12, some was 13, and some was 14, and we multiply it with the percentage. So 12 gets multiplied with 90%. Okay, 13 gets multiplied, let's say there was 8%, no, that's too much, 5%. Okay, 14 was multiplied with 3%, and let's say 11 was multiplied with 2%. Okay, this is just an example. This is definitely not what it is exactly. And once this is done, okay, if we get that 11 times 2%, and I get this answer, and I get this answer, and I get this answer, and I get that answer, all of these are added together, and that gives me what is called a weighted average. So weighted average takes in consideration, it's not just an average between 11, 12, 13, and 14. It takes in consideration that 12 has a much higher probability of existing, okay, than let's say 14 or 11. So weighted average takes all of this into account, so that when you read the atomic mass that is recorded on what we call the periodic table, the atomic mass for carbon is 12,011. that doesn't mean that we've got 6 protons plus, because carbon always has 6 protons, it can't have comma protons, okay, and then 6,011 neutrons, okay, that's ridiculous. Neutrons, it has to be a whole number, but this 6.011, this is the average number of neutrons we will get, just like the average between 3 and 4 is 3.5, okay. In the same way, if we take the average number of neutrons, we'll have 6.011. I hope that makes sense and I didn't just confuse you. The last thing I just wanted to mention was the relationship between electrons, protons, and neutrons. One very interesting thing is that electrons and protons attract each other. Okay. And protons and other protons would repel each other, which is very strange why so many protons will then stay in such a small space. I agree that's an odd thing. Electrons will also repel other electrons, and we'll use this little e to show electrons and a lowercase p to show protons. Okay, neutrons, well, they're neutral, they don't care, that's why we call them neutrons. Electrons and protons attract each other, protons repel protons, electrons repel electrons. So what we do is we say, okay, electrons are going to be negatives and protons are going to be positives, okay, and we're going to call this a charge. So an electron is a negative charge, and a proton is a positive charge. So if I look at an element, in other words, that element has a lot of atoms, and some of those atoms gave away electrons, and in general the electrons should be equal to the protons, but because some of the atoms gave away their electrons, those atoms have become positive. Why? Because they have now less electrons than protons, so they become positively charged. And later we'll learn that a positively charged atom is called a cation and a negatively charged atom is called an anion. But let's not get into that just now. A quick revision: an atom consists of a nucleus and an electron cloud. Inside the nucleus we find protons and neutrons, and inside the electron cloud electrons float around in there. Now the proton is what determines what type of atom it is. A certain number of protons will tell me exactly what type of element it is. A different number of protons would be a different element. The neutrons are usually the same in number, but if it's not, that different atom that I get is still part of the same element, but it is called an isotope. So an isotope is the same element but with a different number of neutrons. When I add the neutrons and the protons together, I get what is called the atomic mass. The atomic mass is therefore the sum of the protons and neutrons. But since there's different number of neutrons, we have to use some sort of average to use in our calculations. And what is used is called a weighted average. That weighted average is then recorded on what we call the periodic table, which you will learn more about. Then electrons are called negative charges, protons are called positive charges. They have attractive effect on each other, so they attract each other, while electrons will repel other electrons and protons will repel other protons. Neutrons, on the other hand, is completely neutral. They aren't attracted or repelled by any of these. Well, it was great having you for this lesson. I hope you learned something. I'll see you in the next one.